Today we are looking at Unit 6. So we are at the end of the unit. This has been a fairly long unit. Seems like we've been doing this forever. So we started back, probably a month or so ago, and lesson 1, we did numbers raised to a power. So we looked at like 2 squared was 4 because it meant 2 times 2. And 3 to the third was 3 times 3 times 3, or 27. And then we learned about the caret key, the caret button on the calculator that looks like that. And we know that that means that we can do an exponent. And so let me pull up my calculator quick. Okay, so if I wanted to do 5 to the 7th power, I would hit 5, the caret key, and then 7 for the exponent, hit enter, and we get 78,125. Okay, then in lesson 2, we did variables raised to a power. And so we looked at like x to the 4th, and we talked about the fact that that meant that x was being multiplied by itself 4 times. If we had more than one variable, if we expanded this out, a was being multiplied by itself 3 times, then b was being multiplied by itself 4 times, and c was being multiplied by itself 3 times. And I made you write that out. And I made you write that out so that it got stuck in your head that that's what that meant. That when you see this, it meant this. We also went from this back to writing the exponents so that you understood that a power meant that that thing was being multiplied by itself, whatever the power number of times it would be. Because knowing that helped you with the simplification problems that came next. Lesson 3 was on multiplying powers. We know that x to the 4th times x to the 5th means I have 4 x's being multiplied together. I have 5 x's being multiplied together. So I have 9 x's being multiplied together. 4 plus 5. If I have 3 a's being multiplied together and 2 a's being multiplied together, as long as I am multiplying this stuff and this stuff, then I would get a to the 5th and b to the 5, and 1 is 6. Multiplying, careful, multiplying doesn't mean adding. Multiplying powers means you add the exponents. Okay, so we're adding the exponents when we multiply. And again, this goes back to this, knowing that a to the third, b to the fifth was 3 a's and 5 b's, and this is 2 a's and 1 b. We put them together, we have 5 a's and 6 b's. We're adding those powers together. Then lesson 4, we went to dividing powers. And we looked at problems that looked like this: a to the 7th, b to the 11th, over a to the 3rd, b to the 20th. And we talked about the fact that if we are dividing, then on the top here I have 7 a's. I'm not going to write them all out. I have 3 a's. I don't want to write all them out, but I know that all 3 of these would divide out with 3 of these. 7 minus 3 is 4. And then if I have 11 b's on the top and 20 b's on the bottom, I don't want to write out all 11 b's. I don't want to write out all 20 b's and then start crossing off pairs. I don't want to do that. I know that all 11 of those are going to divide out, and I would be dividing out or crossing out 11 of them on the bottom. Well, there are 20. I cross out 11 of them. There are 9 left. So on the top, we have a to the 4th. On the bottom, we have b to the 9th. When you're dividing powers, you are subtracting exponents. And again, this ties right back into this again. Then we moved to power to a power. And we looked at problems that looked sort of like this: 2 squared, a to the 5th, b to the 9th, all to the 4th power. Well, when I have powers inside of parentheses being raised to another power, then we multiply the exponent. So this is 2 to the 2 times 4 is 8. A to the 5th to the 4th, 5 times 4 is 20. B to the 9th to the 4th is B to the 9 times 4 is 36. And you could do 2 to the 8th, which is 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 8. I think I'm just going to punch that in. 2 to the 8th power is 256. Then we went to negative exponents. And we said that exponents don't like to be negative. And that the way they can change from being negative is if they jump across the fraction bar. Now, that's not what's actually literally happening, but that's what it looks like happening. Okay, so So if I have a to the negative third, b to the over b to the negative fifth. This exponent wants to become positive, it has to jump to the bottom. This exponent wants to become positive, it has to jump to the top. So on the top, we have b to the positive fifth power. On the bottom, a to the positive third power. They just jump across the side of the fraction bar to become positive. We also talked about 0 as an exponent, and we learned that anything to the 0 power is 1. Even a variable. Okay, then we move to negative exponents with negative bases. Okay, and we talked about the fact that if we have negative 1 squared, that means negative 1 times negative 1, we're going to get a positive 1. If I have negative 1 cubed, it means I have negative 1 times negative 1 times negative 1. Two of them become positive, but the odd one out ends up making my answer negative. And so we talked about the fact that if we have even powers, we're going to end up with a positive answer. If we have, and that's if you have something, a negative raised to an even power. If you have a negative raised to an odd power, then the answer is negative. Okay, and so for example, if I had negative 3 to the negative 4 power, well, first of all, this is a negative exponent. It wants to become positive. It has to jump across the fraction bar. There is no fraction bar, so we can make it a fraction. Then this is going to jump to the bottom and become negative 3 to the positive 4 power. Then if this jumps down to the bottom, there's got to be something left over. There's always a factor of 1. Then here I have a negative number being raised to an even power. I'm going to get a positive answer, and 3 to the 4th is 81. Okay. If I had negative 2 to the 3rd power, a negative number raised to an odd power gives us negative 2 to the 3rd, which is negative 8. Okay, then we started applying our exponent ideas. And the first thing we did to apply was scientific notation. And we said that if the exponent is big, we have a big number. I'm sorry, not big. If the exponent is positive, we have a big number. 3.59 times 10 to the 11th power. That exponent is positive. This is a great big huge number. If the exponent is negative, we have a tiny number. If I have 4.98 times 10 to the negative 7th power, that is a really small, tiny number. If we're going to convert to scientific notation, then the decimal point has to move either left or right. We look at the exponent. This is positive. That means the number is big. To take 3.59 and make it bigger, we would move to the right. So we would have 3, 5, 9, a bunch of zeros, and we would move that decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 right there. So we would have 3, 5, 9, and then 1, 2, 3, 1, 2, 3, 1, 2, 3. And so this becomes that number. Whereas if we have a negative exponent, this decimal point has to move to the left to make the number smaller. And so we would have a bunch of zeros. And the decimal point would start here and move 1, 2, 3, 4, 5, 6, 7 places to the left, giving us 0 point. Then we would have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 4, 9, 8. And so we went from scientific notation to expanded form. We went from expanded form back to scientific notation. Then in lesson 9, we looked at radicals. We looked at, for example, the square root of 25 being 5. The square root of 49 is 7. The cube root of 27 is 3. The cube root of 125 is 5. We also learned that we can do roots that are even higher. So I could do the 5th root of 3279. And on our calculator, we learned that we would then punch, since we're doing 5th root, I would put the 5 in first. Then I would do 2nd caret so that we get the root symbol, and then we would have 3279 and hit enter and get 5.05. Okay. And so we were learning with the calculator that you use 2nd caret. And that helped us find roots. Then we went to area, and we looked at basic geometry shapes, basic geometric shapes. We did a square, and we learned that the area formula for a square was s squared, the length of a side squared. Oh, thank you. We did a triangle, and we learned that The area formula triangle was 1/2 base times height. And we also talked about the fact that the height forms an H in the picture, and that the height sits on the base. So this right here is the height, and this is the base of the triangle. And then we did some other basic shapes like a parallelogram and a rectangle, trapezoid, circle. We also found out that we have a formula sheet so that we don't have to memorize those formulas, and that all of those are on the formula sheet. It's knowing what numbers to take off the picture and plug into the correct spot in the formula. Then we did solid figures. And we found out there were 3 classifications. The first being prisms / cylinders. These have 2 bases, and they have rectangles for lateral faces. The sides of a prism are made up of rectangles, except for a cylinder. Cylinders circle at the top and bottom with a lateral surface, but the idea is basically the same. And we learned that prisms are named for their base. Okay, so you may have a you might have a hexagonal prism that has a hexagon for the top and the bottom. Or you may have a triangular prism. Where the triangles are the bases. And that a cylinder was very similar to a prism, except for the base. The 2 bases are circles. And we learned to find base area, lateral area, surface area, and volume. We also learned that we have a formula sheet for our solid figures. We don't have to memorize the formula, but you have to be able to pull the numbers off the diagram and put them in the correct place in the formula. Second classification being pyramids, cones. They have 1 base, and triangles for lateral faces, except for the cone. The cone has a lateral surface, and that pyramids are named for the base. So you may have a square pyramid. And again, we were finding base area, lateral area, surface area, volume, and being able to pull the values off of the diagram to put in the correct spot in the formula. And the third classification was a sphere. A sphere is like a ball. It has no base or bases. It has no lateral faces. But we can find the surface area and the volume. And so we, again, looked at problems where we were taking the measurements off of the diagram and putting them in the correct spot in the formula. Okay. And then finally, lesson 12 was Pythagorean theorem. And it says if we have a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. We learned that the side across from the right angle is always the hypotenuse. We also learned that it is always the longest side. And we had situations where we were given the two legs and had to find the hypotenuse. So for example, 3, 4, and x, and a squared plus b squared equals c squared. The two legs are 3 and 4. 3 squared plus 4 squared equals x squared. 3 squared is 9. 4 squared is 16. 9 and 16 is 25. Take the square root of x squared. Take the square root of 25. The square root of x squared is x. The square root of 25 is 5. The missing side here is 5. But we also had problems where we were given the hypotenuse, but one of the legs was missing. And so a squared plus b squared equals c squared. This is a. B is x. The hypotenuse c is 11. 6 squared is 36. That should be squared. 11 squared is 121. And then we've got to get x down here by itself, which means that I've got to get x squared by itself first. There is an understood plus sign in front of that 36. So the way we can make that disappear is do a negative 36. Positive 36 and negative 36 add up to 0. So that disappears. That's what we want. We want this left over. Well, if I do that on the left, I have to do that on the right. So we're left with x squared on this side, and on the other side, 121 minus 36 is 85. So we then take the square root of x squared and the square root of 85. The square root of x squared is x, and the square root of 85 is 9.22. So the missing leg is rounded off 9.22. So it seems like a long time. We've been on this unit for a very, very long time. Several weeks, more like probably about 2 months.
This has been a production of D&J Designs and MathMan 1962. If you like this video, click on the thumbs up. If you want to be notified when new videos are posted, click the bell. And if you want to see more videos like this one, click on the subscribe button.